Okay, good afternoon, all. Maybe it's possible that someone would let me know if you can hear me correctly or not. At least I know that those settings are correct. Okay, I see already some thumbs up. Great. Well, welcome to today's webinar. My name is Marit, and I will give you an overview of the BIM workflow or the link between Tekla Structures and SCIA Engineer. So let's take a look to that. Now, the first thing I want to take a look into is where to find our plugin. If you want to install the plugin, you can always find it on our website on the download page. You can find both the Revit plugin and the Tekla plugin. Keep in mind when you take a look into our download page and want to install the link that you check that the version of Tekla you use and the version of SCIA Engineer you use are supported and that you install the right one. Do you use the latest version? Then I would always advise you to install the latest available link, since it could be that some issues were solved in the latest version. Today we're going to use Tekla 24 and SCIA Engineer 24. Whenever you install a new plugin, also keep in mind that the old plugin needs to be uninstalled from your device first. So that's always the first step that you take there. Now, other than this download information, I will go over this information with you. At first, I'm going to show you what the difference is between the direct or file exchange. We will focus on the direct exchange today, but I will explain the difference in a moment. All the options you see here, starting from chapter 2 until 5, will be shown to you with an example project. So we will open Tekla Structures and we will take a look into those properties. We're going to take a look into what this example project is, what kind of elements are created. Then we are going to take a look into the mapping options for materials and families. Then we take a look into the export and lastly into the import options. Of course, at the end, if there are any questions, I will answer them. Now, as said, as first, I will show you the difference between the direct or file exchange. Now, what is the difference? If we take a look into the file exchange, it can be quite a useful tool for a user who only uses Tekla Structures and has no usage of SCIA Engineer. This means that they can export a Tekla model through a file, which is a T2S file, to SCIA Engineer with a file in between. The user of SCIA Engineer can then afterwards import this file as a Tekla file or update an existing file with this Tekla file. The other way around, it can be done the same. If you have a SCIA model which you like to export to Tekla Structures, then you can first make the export in SCIA Engineer to Tekla. This will create a SCIA to Tekla file, as well as a def file, which is important to include it if you share it with someone else. And these files can then, with the plugin, be imported into Tekla Structures. So these are the steps when you use the file exchange. There is a file in between which you can share with different colleagues, other parties, and so on. This is quite useful if you do not have a SCIA Engineer license yourself, but you do use Tekla Structures. No SCIA license is required to make the export in Tekla Structures or to import these files into Tekla Structures. The next option is the direct exchange, and with this exchange you perform an immediate export. If you start the plugin from Tekla Structures and you make an export, SCIA Engineer will be opened immediately on your computer and you will need an active SCIA license to do this. The other way around, it works the same. If you import anything in Tekla Structures, it will take a look in the model you have opened in SCIA Engineer and import it directly. So in this case, you have installed both Tekla and SCIA Engineer. Now, for the rest of the part, we're going to take a look into an example project as set to show you guys that we have a pre-recorded video, which I will share with you in a moment. If there are any questions, you can leave them in the chat. If I can answer them immediately, I will answer them. Otherwise, I will discuss them at the end of the webinar. Okay, I see before I start the video, there was indeed already a question about that file export when you want to create a Tekla to SCIA file. It is indeed quite useful to install SCIA Engineer. You do not need a license to do so, but then you can select the right version when you make an export. As far as I know, it is not necessary, but I haven't tested that, so maybe that's something I need to check afterwards as well. I will write it down to see if my information was correct here. Normally you can see my video already, so I will mute myself and I will start. To take a look into the possibilities of the Tekla Structures plugin of SCIA Engineer, I will open an example we will take a look into. We are going to first check the export from Tekla Structures to SCIA Engineer. Later on, we will discuss whenever we'd like to export a project from SCIA Engineer to Tekla itself. This project contains multiple types of materials like steel and concrete, and also uses different types of profiles in Tekla Structures. On the left part right now, you find our steel hull containing of multiple steel profiles. For example, the column here is an IPE 300. We can check the same for some of our beams. Here I find an HEB 500, and for our trusses as well, I see here for the long beam an HA 120, for my vertical part a rectangular hollow cross section, and then for the diagonal an L angle. So we added different types of profiles to show you the different options to export it to SCIA Engineer. You can always check the different parameters in the properties of that profile. On the right then, you find a concrete part containing of a few different walls with the same thickness of 200 millimeters, and you also would see an opening in one of the walls on the right. Then for the concrete beams, we will find a specific eye cross-section with a few parameters. These parameters are filled out manually, so it's a specific type of cross-section you can create here. In this case, these are the parameters that you can find. If we then take a look into lastly our column, we will find that this column has a rectangular cross-section. So let's take a look into those properties. And there we find both the height and the width is 500 millimeters. These specific type of cross sections we will be able to export to SCIA Engineer as well. Then lastly, I added some extra data like the reinforcement to our beams. So you can find that there are a few bars created, both stirrups and longitudinal reinforcement, and you can always find the properties of the material as well. I did the same for our 2D member. There I added a 2D reinforcement mesh, but in this case I can already give you a heads up. This reinforcement cannot be exported from Tekla Structures to SCIA Engineer. The other way around, it will be possible, but that's something that we check later on. So after taking a look into these properties, we can take a look into our opening here. This is created with the command polygon cut, and we will be able to export this opening to SCIA Engineer as well.
Now, what is important before we try to export this model is creating an analytical model. And you can find the creation underneath the tab Analysis and Design. There you can find the command AND models. It is necessary to create this model since this will be exported to SCIA Engineer. In this case, two models exist, Model 1 and Model 2. The differences in these models are limited. The only thing that is changed in Model 1 is that a modeling mistake was created. Normally, this analysis model is created almost automatically and you do not need to modify it very much. In this case, I made sure there was a mistake in this opening where some lines overlap, just to show you what it could happen when you try to export this to SCIA Engineer. Model 2 is totally fine, so in most cases we will use this option. You can check the properties of these analytical models, but I will not go into further details about those different options here. What was not added to this model were loads and load groups. We didn't modify those since we can advise that whenever you would like to export this model to SCIA Engineer, that you can create those loads, load cases, and so on in SCIA Engineer itself. What we can check though are the member releases of the members in Tekla Structures. For example, if you open the default properties of a steel beam, you will find that you can check the start and end releases. These will be by default be used to create your analytical model. So whenever you make an export, these will be taken into account and hinges will be created unless you choose to ignore those. So for example, now I selected one of our beams and it should have hinges at the end once we export it to SCIA Engineer. Our diagonals are also seen as a steel beam, so there we find the same. And when we check our small rectangular hollow cross sections here, the vertical part, it's seen as a steel column. So if you check those properties, we find that both at the start and the end, we find a fixed bolt. So those elements will not have hinges at the moment. Now again, you can change those in Tekla Structures, but you can also define those elements in SCIA Engineer itself. I'm just going to change my rendering for a moment just so we get a full look on the model again. Now that we checked all the properties of our model, we can try to make the export to SCIA Engineer. Whenever you're looking for the plugin, you go to the applications on the right and you can find SCIA Engineer underneath the application category. You can also search for it via the top bar here. So there you will be able to find it. You can open it by just double clicking on it. This will open a new dialog where we can find all the different properties that we need. What I would like to start first with are the mapping details that you can find on the bottom left. Here you can find what is mapped from Tekla Structures to SCIA Engineer or the other way around. In this case, we find materials, cross sections, and parameters. So let's take a look into what we find in these mapping details. First of all, the materials, I see project mapping here is empty. If we switch it to user material mapping, I see that some previous export options were saved. So in this case, I previously made an export and I already mapped a few materials. And I see, for example, an undefined material is listed here. Today, I will show you everything from the beginning, so I remove everything that was created here. Another tab you find are general materials, and these are things you cannot remove. These are automatically created by the plugin based on the Tekla Structures materials and the SCIA materials, so those should be mapped correctly. We can check those, but in this case, we don't need to. Normally, everything here is fine, so we can close this up. We can do the same for our cross sections. Cross sections are also mapped from the Tekla Structures section to the SCIA Engineer section, which you can see on the left here. In this case, again, I previously made an export and saved those export options, and therefore this mapping table isn't empty. But I do see there is a mistake here on the bottom, so probably something I did wrong before. So let's remove these as well so we can show you the mapping from the beginning. I see the same cross section is twice in the list, so there is definitely something performed wrong in a previous export. Apart from user section mapping, you cannot take a look into anything else here. That's only for the materials. Now, lastly, we also have some parameterized profiles used in Tekla, and those can be found in a second tab. You can find here that we linked the parameters from Tekla Structures to parameters in SCIA Engineer. Here as well, I will show you how to do this. So we will remove all the options that we have performed right here. So we will check how to make these parameters linked to each other later on during the mapping and export options. So let's select them all and delete them and close this menu. Now, if we take a look into the properties on top, we can make a few settings there as well. First of all, the national code on top, which you can select. And second of all, we select the right SCIA Engineer version. If the right SCIA Engineer version is not listed here, you can click on the plus icon right next to it, and it will open a Windows folder where you can make sure you select the right installation folder of SCIA Engineer. So right now I'm navigating to the installation folder of SCIA 24, but this was already added, so I haven't made any changes. Now right below that you find a very interesting option, and that is the direct or file exchange. What does this mean? When you use the direct exchange, SCIA Engineer will be opened immediately and your project will be immediately exchanged to SCIA Engineer. This means you need an active license of SCIA Engineer to perform this action. If you do not have a SCIA Engineer license, you can use the file exchange to make the export. This will not open SCIA Engineer for you, but this will create a Tekla to SCIA file. This .t2s file can be then shared with another party who will be able to import it into SCIA Engineer. Today I will focus on the direct exchange. So that's the one that we will be using today. Right below that, you can export either the full model or a selection. If you want to make a selection, you can toggle this on and you can just go to Tekla to make a specific selection. In this case, we will keep it on the full model. And then lastly, you can choose to export as a new project or update an existing project. In this case, we start off with a new project, and later on we will see that whenever we make a change in Tekla, we can use the option Update Project to update the already existing export that we created. The options on the right in the dialog we will discuss later on. So let's start our export to SCIA Engineer. First of all, we need to select the analysis model we would like to export since multiple are available. I select Model 2 here to make sure we do not export the mistake. Now in this screen, you get to see what is happening on the bottom, and on the left you see the total amount of items and if anything is ignored or failed. On the right, you always get a log file. That is a list, and later on you can always save that. Now in this table, we first define the mapping materials, so we select the right materials for all the options that we find here. You can When you check the list, only select the ones for which the naming is similar. If you want to see everything, you can toggle on Load All and you can make a different selection. But in most cases, those limitations are totally fine. You can also export the material as unknown. In that case, you need to make sure that you review those properties in SCIA Engineer and maybe even change it later on in SCIA Engineer. Now you can hit save and we continue the export, and next up our cross-section mapping will be shown. Now for a lot of those sections you will see that the right one is selected immediately. I see here are the HEB 140, the HEB 500 and so on. It seems like the list is correctly applied. If you want to change anything here as well, you can always click on Load All to make a different selection. So even our rectangular hollow cross-section is recognized correctly, but if I would like to change this because there is a mistake, you can click on Load All and make that setting yourself. Let's move it back and let's toggle off Load All to make sure the right selection is made here. And of course, right below it, we find some HEAs again and an IPE 300. Now we modeled our steel cross sections. What you can also do is export them as numerical, so that only the numerical properties are exported to SCIA Engineer, but the shape and so on will be ignored. And other than that, you can also choose export as general. This will create a general cross-section in SCIA Engineer, which would be the same as if you imported an AutoCAD file into SCIA Engineer to create a cross-section. So it's a similar cross-section, and you will be able to edit the cross-section later on as well. So it's not fixed. Lastly, we of course need to export or map our concrete cross-sections. First of all, we need to select the right profile shape. And then second of all, we need to select the right section. Now I see I first need to select the profile shape, so let's start there. For that first option, we know it was an I shape. It's possible that I cannot map every parameter to SCIA Engineer, and if we check it right here, we will have a bit less parameters than our section in Tekla Structures. But we can still use the existing parameters. So let's see, the top was number 1 and the bottom was number 2, so we can link those parameters correctly, and you can always check the size on the right as well in the values. Now, as said, there will be 2 parameters that we have not used since our I shape looks a bit different from it in Tekla Structures, but the shape is not exactly available in SCIA Engineer. But right now we choose to map it like this. I will later on show you what happens when you export it as a general cross-section. So that will be something for afterwards. Now that we have mapped this cross-section, we can go on to the next, and we can do the same for our rectangular cross-section. So let's click OK, and then move on to the next one. There I select first my shape again, it will be a rectangular shape, and I see if I click on the shape that it's mapped automatically. I do not need to select anything here. And then we hit save. Our export is continued. On the left I see opening SCIA Engineer project, so it's prompting SCIA Engineer to open right now. And then we will be able to check all the properties of this SCIA Engineer project. See, it's loading, not yet imported. And there we see our results. Let's check if the output is the same of all our elements. Select a wall, for instance, and I see the thickness here indeed is taken into account, and the material is exactly the same as inputted as well. And we see for another wall that the opening that we created is imported as well.
We can check the cross-section and the hinges of our elements as well. Let's select one of our steel beams as we did in Tekla Structures. We see the cross-section is filled out, but also that there are hinges added to both ends of this beam, as we stated in Tekla Structures as well in the analysis properties. For our vertical element, we can check this as well, and here we see that no hinges are added. We also already see that the cross-section is set up correctly. Now, to verify those cross-sections, we can check the properties here as well in our library and see if everything is exported as expected. For all steel profiles, you will see that all elements are linked to the profile library you find in SCIA Engineer, and you will be able to edit that if necessary. For our concrete members, you will find different properties since those were parameterized cross-sections. So let's check those for a moment as well. If we take a look into those, you can find all the properties, of course, but you see you can fill out the different parameters as well here. And the same for our rectangular cross-section, of course. Then, apart from these cross-sections, we also imported the reinforcement, and we can check those as well. If you just select them, you can check it. Now, as stated, the reinforcement of the 2D member could not be imported, so that will not be available in the SCIA model right now, but the 1D reinforcement will be imported as expected. You can check the properties, but we will find the same bars as we inputted with diameter 16 for the longitudinal reinforcement, for example. So that will be the same as what we expected. What is important here as well is that our analysis model seems to be connected in each node. We do see that some alignments can be different. I see a few members here are aligned to the bottom, other will be aligned in the center, but it could be that an eccentricity like this beam is used with an eccentricity of minus 250 millimeters. I will take a look into those properties later on. But if you check all the system lines, they seem to be connected properly in each node, and that was the most important. Now, what happens if I use model 1 to export the analysis model, where I made a mistake in the opening? Let's check that. Instead of updating this project, I will export it as a new one just to see what will happen. So I will close my previous export options, and I will just create a new project as we did before, but then with the analysis model, model 1. The export will be done the same. It could be that a warning would be represented if an item could not be created. If the item could be created, then we most likely see an issue in SCIA Engineer. So let's see. In this case, it looks like the project can be created. So let's take a look into the results once it is done. And I do see where the mistake was found in the opening. I see that the node is created, but the shape of the opening is actually incorrect. So whenever something like this happens, you should be able to verify what is happening in SCIA Engineer. Now we're going to close this project as well. Instead of now exporting this file with this incorrect analysis model, I'm going to keep using model 2. And I'm also going to show you what happens if that I section we used for the concrete beams is mapped as a general cross-section. So let's make an export again, a new one as we did. And when we are asked to map our cross-sections right now, instead of selecting the I shape, I'm going to export this as general, which means that I do not need to map any parameters. This cross-section will be generated in SCIA Engineer. So again, the same export is created right now. That should be done. So let's close it here and take a look into SCIA Engineer. Here we are again. Now here we don't see anything different, but if we take a look in our cross-section library, we should see that this cross-section has a different type. Right now it's a general cross-section, which means that we can still edit the shape, but the shape will be exactly the same as what we defined in Tekla, while before we made a simplification to create an I shape. So that's the difference here. And as said, if you want to edit it, you can take a look into the properties and you can edit it with the cross-section editor, which would be the same as if you imported this through AutoCAD and wanted to modify it afterwards. So that's quite useful. Now that we have created this one, I'm just going to cancel my changes. The rectangular cross-section we find in our model will be exactly the same since we haven't changed anything there. Now, a few minutes ago, I already let you know that we used some eccentricities in this model, and there's actually another change that we made in Tekla Structures, and that is rotating some columns. You don't see it right now if we only show the system lines, so let's toggle on our shading and our volumes. That way we can check it a bit better. For the columns, it's a rotation of 90 degrees. If you select them, you can check it, and you will also see that it's different from the columns on the right from it. So the LCS rotation is 90 degrees. The same for the column right next to it on the left, and on the opposite side of our structure, we find exactly the same. This is done in a similar way. In Tekla Structures, we define some properties, and these properties are taken into account. The same was done for beams like these. The eccentricity EZ is placed on minus 250 millimeters, while the member system line is still at the center. We did that for a few different types of beams. I think the beams in the opposite direction are exactly the same. There we are, also an eccentricity EZ, which is taken into account. Let's take a look into Tekla Structures to see where we define that. If we would select the same members like these columns on each side, we can check the differences. So let's select those two and go to the properties. The properties are found underneath the position. There you can find vertical, rotation, and horizontal. Vertical and horizontal are related to the system line. Where will the system line be located? And rotation will tell us to which side does the element need to be rotated. If I change this to top, it will be exactly the same as what you find for the other columns. So let's move it back to front here. We can check the same for those beams. What have we indicated there? Well, for the position there, we left the system line on the middle. So here, when we check the position on plane, rotation, and at depth, we see that there we have on plane is middle and at depth is middle as well, but the eccentricity is set to minus 250 millimeters. So the system line remains in the center, but an additional eccentricity is filled out. So those properties are taken into account as we expect. If we now would change this manually, and we would update our SCIA project, we should see that that change is taken into account. So in this case, we can check what happens if we change this now from middle to front, for example, and modify it. Of course, visually, we see that it has moved, but what happens when we export this to SCIA Engineer? And instead of closing the original project, we are going to update that project. So let's open our plugin again. Instead of new project, choose update project. And other than that, we select exactly the same. So the second analysis model without a mistake. The mapping needs to be selected. Cross-section mapping seems to be fine. And then we can just press OK to export it. I do see a warning here that it could not open the project, but I do see once I closed it that it was able to update the project. So I'm not sure what happened there. But right now you see that my eccentricity is still there, but the member system line was changed to bottom because we changed it in Tekla. So the wording is different, but they will be taken into account when exporting those members. Let's now change this property back in Tekla Structures. I will move it back to the middle. And by making this update, I've shown you how you can actually make changes in Tekla Structures and still take them into account in SCIA Engineer without removing an element. Now, some other things we can do is making some other changes to the project, like moving a wall around, making a column longer with the properties of that column, changing a few properties, and so on. That way I can show you what updates will be taken into account and so on. The great part about it is that if you already have added some loads in SCIA Engineer, that those will not be removed because the same item is kept, but the properties are changed. Now I did remove a beam here, so that beam should be removed in SCIA Engineer. And now let's change one of our cross sections as well. Like choose one of our concrete beams here and change it to a different section, for example, a steel section. So I'm just going to change it to an I shape, let's say an HEA. There we are. Now that is modified, I'm also going to modify the material. So let's select a steel material. I will use the same material as we've done for the other elements. Once I modify this, that should be taken into account correctly. Now that I made these changes, let's update our project. So whenever you export to SCIA Engineer, choose Update Project, so we do not need to close the one that we already created, and then choose Export to SCIA Engineer. Keep in mind that the options on the right can help us ignoring a few elements if there are elements you do not like to update. For example, we can choose to ignore unmodified members. So in this case, we can toggle that on to make sure that our import time is reduced, but it won't make a big difference since the export was quite fast. Let's start the export again. We perform the same steps as before, analysis model, now the material mapping, and immediately after this, we will be able to perform the cross-section mapping, which is saved, and it will open our SCIA Engineer project again. I see that it's done in the log, so we can check it in SCIA Engineer. Let's toggle on the shading for a moment as well, so we can see what is going on with our walls. And then we see the wall there on the side is moved outwards. Other than that, we made a few different changes, of course. The beam was removed, that is removed. The cross-section of my member should be different. And I see the column on the side is made a bit longer. Let's check the cross-section, and right now I see that's an HEA. So it is modified as I expected. So that's what we can tell about exporting from Tekla Structures to SCIA Engineer. But what now if an engineer makes changes to our SCIA model, like removing this wall, changing the size of this opening, maybe changing some other things as well. Let's move this opening first. Let's just change the size here by moving a few nodes of this opening. And so on. And let's check later on how we can import this back into Tekla Structures. I'm going to add an opening onto D on a different wall to create a new element which wasn't there before. And there we are. Let's change this node back to 0 instead, so not -2 meters anymore, but the Z coordinate will be 0. And then we can change the thickness and a cross section of one of our members. For example, this wall, we can change the thickness. Let's change it to 400 millimeters. And then for one of our beams or columns, let's change the cross section. You can either change it or create a new one. I will change this one to an existing one, an HEB 500. So that's something we can check. Now we go back to Tekla and our Tekla Structures plugin. I close the previous export, and instead of clicking on Export to SCIA, I will click on Import from SCIA Engineer. Keep in mind that everything that you can ignore on the right side, on the top, is taken into account during the import. What you can ignore only for the import are the end reactions. Right now our structure was not calculated, so that would not make a difference if we left it toggled on or not. But to make sure everything is taken into account correctly, I've toggled that one off. Same as before, but now we go from SCIA to Tekla. We need to perform the mapping. So I fill out the right material, and then afterwards we do the mapping of our cross sections. Now the rectangle is quite easy. The thing that will give us some issues is that specific cross section, since we exported it to SCIA Engineer as a general cross section. So there are no parameters we can link. We can only fill out the parameters ourselves in this case. So in this case, I just found the right type for that cross section, and I will fill it out in the properties. Let's just check the properties of this beam. Yeah, there they are. The beam is still selected, so we can still check it. And we can fill out the right properties. So the sizes are listed there on top. If we did not create a general cross section, but it was mapped as the I shape as we did before, there would be some parameters which we can link to this. So that's something to keep in mind whenever you have general cross sections, that you will need to map it when you come back to Tekla Structures. And depending on what you have used, you will need to fill out some properties. Now that those are filled out, we can do the same. We save our cross-section mapping. And then our import will be created, and you should see some changes would be made. I see my column on the left is already a bit shorter. I see some positions are updated whenever necessary, and we can check the other changes we made as well. So let's close this menu and see what we can find. Our column in the back is now in HCD 500, so that is changed. Our wall is gone. Our column as set is a bit shorter, and if we check the values in the properties, you will see that the value bottom is set to 0 again. So that's right. The new opening is created. The only thing I noticed is that there is a slight issue in the wall here up front. So let's take a better look into that. It does look like my opening is changed correctly. But even when I toggle on shading, I see that the original opening is still there. Now, the reason for that is that the original opening is a polygon cut, while the opening that is imported right now, if we select them both, you will see that that is different. It's a concrete cut. So we can remove the original one. The original was not removed automatically. So here you see both the polygon cut and the concrete cut. So that's just a difference there. In this case, I will just remove the polygon cut, which was the original one. It's something to keep in mind that when you import it back, that the type can be different, and therefore it is not updated. But the opening is still taken into account when coming back from SCIA Engineer. And lastly, we can check the thickness of our wall, which is now set to 400 millimeters. Now we've checked how to create a model in Tekla, import it into SCIA Engineer, update our SCIA Engineer model when we made some changes, or update our Tekla model when some changes are made in the model from SCIA Engineer. Now let's change a few things and let's import a new model from SCIA Engineer into an empty project in Tekla. So I am going to create a new project here. Let's call it SCIA to Tekla, and let's import a SCIA Engineer file into that project. I will not save this project. We will not use it anymore, so we can just close it. Now, it will work similar as what we've done before. We will use the SCIA Engineer plugin, and we will import our SCIA file. The only difference here is that I created a smaller project with a few properties, which we can import into Tekla Structures as well. This new project only contains a few elements, but both a steel and concrete material, as we've seen in our Tekla model. It contains a few plates and 1D members, as well as hinges and supports. Now let's take a look into the loads. I already added some line loads and a surface load
on one of our plates, as well as the self-weight, of course, which is taken into account by default. On my concrete beams, I added some hinges on both sides. I also added a hinge on the edge of a 2D member, but that boundary condition will not be taken into account. My concrete 1D members are rectangles. My steel beams are IPEs 240. Now, what I've added in this project as well is some reinforcement. I do see this hidden right now, so let's make it visible with our view parameters. Let's display both our concrete reinforcement and then the 2D reinforcement regions as well. Now let's take a look into those properties. I imported reinforcement in two ways. The first one is provided reinforcement. I used a template from the concrete settings and converted it to real beams. The other type of reinforcement is user reinforcement, which is modeled with the command 1D reinforcement. Both types of reinforcement will be exported to Tekla Structures, so that will not make a difference. Now we can take a look into the properties of these reinforcements just to verify them later on. For my longitudinal reinforcement, I added 2 bars of diameter 16 on the top and the same at the bottom, 2 bars of diameter 16. For the shear reinforcement here, I see I added some stirrups with diameter 8 with a spacing in between of 0.150 millimeters. You can also find the cover here on the side. For my user reinforcement, I did something similar. On the top and bottom, we will find 2 bars of diameter 16. So that's what you find here. For my stirrups, I find something similar as well, diameter 8, but in here, the stirrup distance is a bit different. It is 300 millimeters. So there is a small difference, and we should see that later on in Tekla Structures as well. For my 2D member, I did something similar, but there I only used user reinforcement, since that's the only type that will be exported to Tekla Structures. I added some reinforcement on the top and on the bottom, so let's take a look into those properties. I did make some differences there as well. On the lower surface, I only added reinforcement in one direction, which is the local X direction, of diameter 8 with a spacing of 100 in between. For the top, I added reinforcement in 2 directions. I did exactly the same in both directions, diameter 20 with a spacing in between of 200 millimeters. So those are things that should be taken into account when making the export to Tekla Structures. Now we do not need to do anything in SCIA Engineer itself. We can just leave it open and open our plugin in Tekla itself. In this empty project, I open the plugin. You can take a look into the import options if you'd like. For now, entry actions will remain ignored because the model is not calculated. Let's import it and we get similar options as we did before. We need to select our mapping for the material as we did. And then we can check our cross sections again. My rectangle is again recognized, my IPE as well. So the import I see here is done without any issues. Some things are ignored, like the hinges, but we will see that the boundary conditions or the releases at the end are taken into account for my members. So that's something we can check. Other than that, we can close this and take a look into our model. Now, in this model, we can take a look in everything that is imported. Let's start off with our loads. You can see immediately that both the surface load and the line loads are imported here, and you will be able to find the load groups on the top. Load case 2 and 3 are imported. The self-weight will be ignored here. We can check the analysis properties of our members as well. You can always check those by right-clicking on a member and clicking on analysis properties there. Now I selected a 2D member, so there's not much to see there, but later on we will check that for our 1D members. Now let's check the cross sections first to see if everything is mapped correctly. I see my column is an IPE 240 and my beam will be a rectangular cross section. So that seems to be correct. Now we can check the analysis properties of our members, and we will see that for our concrete beams that we find that the start release is connected and pinned and the end release is the same. So these end releases are taken into account when you imported the model from SCIA Engineer. Now let's change our view a bit so we can take a look into the reinforcement. I will make sure the wireframe is visible and then we can check those properties. So from the start off, it looks quite good. On the top, I see 2 bars, and on the bottom as well. So let's take a look into their properties. If I select the longitudinal bars, I do find the size of 16 millimeters. And if we scroll a bit down, we can find the number of reinforcement as well, which is set to 2. But that's what we have inputted in SCIA Engineer, so that's correctly taken into account. We will find exactly the same on the top, and then for our stirrups, we will find the same as well. Normally for our stirrups, we should have a diameter 8, so let's check that, and a distance in between of 150 millimeters. So let's see, I see diameter 8, and then if we take a look into the spacing in between, I see that there are 54 elements, and then if I check the spacing, it's exactly 150 millimeters. For the other one, there should be a slight difference. The longitudinal reinforcement is the same, so diameter 16 and the amount of bars 2. On the bottom and the top, the reinforcement is diameter 8, but the spacing in between should be different. That is, in this case, 272 millimeters. Now, before I set 300 millimeters, but if we check SCIA Engineer, we will see probably that the real distance is different. Yeah, so here you see the stirrup distance put in was 0.3 meters, but the real distance is a bit lower. So the real distance is what is taken into account here. So overall, our reinforcement for 1D members is imported. So let's take a look into our 2D reinforcement of our plates. Let's zoom in a bit and you see visually already that there is a difference and also the sizing of our reinforcement seems to be correct, but let's take a further detailed look. I will start here on the top. Let's select our mesh and on the right you can see the properties. You will see that it is a mesh imported through SCIA. If you click on that, you can find the material that is selected. We're going to leave that as is. And if we scroll a bit more down, we can find the distance in between the members and the diameter. And in this case, both directions, diameter 20 with a spacing of 200 in between. For my bottom reinforcement, I will find the same, but in that case, only reinforcement in one direction is added, which was the local X direction in SCIA Engineer. And that's the case, I find diameter 8 with a spacing of 100. For the other direction, I will find a diameter 0 and a distance 0. So that is exactly as we have inputted it. So even if you import a model from SCIA itself, you can import it in Tekla Structures. And of course, the other things we talked about are still the same. You can change something in SCIA Engineer, update your Tekla model, or change anything in Tekla and update your SCIA model, or make a whole new export to SCIA Engineer if you'd like. So that is exactly the same. There is only one property here I have not discussed, and that is the support of our steel members. But that's actually the same as the hinges. We can find that in our analysis properties. If we check the start releases, you see that the start of my column is supported and the end is connected. And that is a fixed connection. So it is still taken into account that there was a support on the bottom there. Other than this, there is also one property we have ignored until now while we made the import from SCIA Engineer, and that is that option end reactions. That is something you can import from SCIA Engineer if you'd like, but therefore we need to calculate our SCIA project. So let's first do that here. I'm just going to run the calculation of this model. And I'll take a look into the results here, but we will import the results then back into Tekla Structures. Normally it shouldn't take long. There the mesh was already generated and now the linear analysis is performed. So we can close this menu and we can go back to Tekla Structures and our plugin dialog to import the elements. Again, this is the same. We go to our applications. I open my plugin for the last time today, and then we can import from SCIA Engineer. Of course, we are going to toggle off ignore the following and make sure that the entry actions are taken into account. The import options will be the same. I will map my cross sections and I will map my material, but I will also get a dialog to fill out a load case or a combination, and I will be able to import those reactions. So let's fill out now classes and then fill out which class I would like to use. Once I press OK, this will be taken into account and you can hit close to close this menu again and take a look into Tekla. Now I won't take a more detailed look into those entry actions, but they are saved in your model. And one thing you can do, for example, is take a look into the attributes of your element. For example, if I right click on one of my members, I can click further on inquire and I can find some results on that part, but also some default data. So on the bottom here, you can find some actual loads and so on. But that's something we will not look further to in detail. It's just something you can know that you can import such data from SCIA Engineer. Useful as well to know is that whenever the plugin makes an export, that you can find the log file in the plugin. Now you can open it from there. We haven't done that today, but there is always a button to open the log file. But those files are also saved within the folder structure of Tekla. So in this case, I opened the training example folder on my computer, and you will be able to find a folder SCIA Engineer here as well. What will you find here when you click on it? Well, you will find that example that is exported. If you save it here, you can find that file, but of course you can save it elsewhere after making an export if necessary. And you will be able to find all the reports, XML files, and so on here. In this case, if you want to check a report, you can find it by double clicking on it, and you can find all the existing reports that you created during an export. You will see I created a few now, but the last one, for example, is this one. And if I double click on it, you will see that I can check what happens during the export, is everything imported or exported, what is the material mapping, what is the section mapping, and so on. So it's just something you can check. You see that some things will not be updated or anything could be wrong, and it will be highlighted in here as well, which can be a bit better to read. So that's just something you can check later on, or you can forward it to someone when they need it. Lastly, in here as well, if we go back to our report, we can go back to the SCIA Engineer folder, and you will find that this SCIA to Tekla file will be created here as well as the def file. Whenever someone wants to import a Tekla model into SCIA Engineer and you use the file exchange, these are the types of files that will be created. The user of SCIA Engineer can import this file into SCIA Engineer with the command open from and then a Tekla file and choose this one. Make sure that whenever you forward a SCIA to Tekla file to another user, that you include the def file when it is available. Otherwise, the user will not be able to import it. In SCIA Engineer, you can import these files by going to File, Open From, and then Tekla file. With this menu, then you can select the right files. For example, this training example, if I went to SCIA Engineer, I can find the training example, which is a Tekla to SCIA file. The other way around, you can do something similar. You can export it from SCIA Engineer and you can import it with the plugin in Tekla if you use the file exchange option.
Okay. I hope that was already useful for you guys. I would like to go over some of the questions that were asked already. Most of these questions were linked to the limitations of the plugin. If you want to know more about these limitations, you can actually find the help document in itself. Let's open that one for a moment. I have Tekla opened here and the SCIA plugin here as well. When you have the plugin opened on screen, you can find the help document by clicking on the button on the bottom, help. That button will open this file, which contains the release information and so on about the plugin, but it will also take a look into the limitations. For example, some questions were about curved members. Those are at this moment not supported. I do need to check the same for curved walls, but I assume right now those are not supported as well. Then there was another question about the integration of the profile catalog, and that's kind of related to the settings you use in Tekla Structures itself. Depending on which environment you choose, the profiles are loaded into Tekla, and this is also linked to SCIA Engineer. In this case, for this project, I used the Netherlands environment. I assume we can check it if we go to settings. Yeah, here below you can find it that I used the environment Netherlands, and therefore all these profiles were listed in my document. And this can be quite important when making an import from SCIA Engineer as well. If I would have used the blank project, for example, then it could be that whenever I run the import, that the mapping table remains empty and that no options are there. So it is quite important to select the right environment there. I see if there is anything else. I think all the other ones were answered. I see a new one popped up. Let me check. I'm not sure what you want to add further. You talk about loads and so on. You import loads to Tekla Structures as well. You can do that in both ways. You can also export them to SCIA Engineer if they are defined. But the nonlinear functions and hinges, that's probably something I need to check. As far as I know, those will not be taken into account when you import them to Tekla Structures, but it might be something that I need to check afterwards to give you a full answer about that. Okay, for now, that seems to be all the questions. If I said that I will answer it later on, I will contact you afterwards and I will give you an answer about anything that you're unsure of. If you have any questions afterwards about this plugin or you run into any issues, anything that is not supported, do not hesitate to let us know via our general email address, support@scia.net. Also, if you want to talk about an improvement, something that doesn't work right now, but you would like it to work in the future, you can let us know as well. I don't see any other questions pop up right now, so I wish you a very nice afternoon then, and hopefully let us know what you think.